Graph has the equation shown. In fact, this is an implicit equation because we've got x's and y's all kind of together. We don't just have a y equals a function of x. And to find dy by dx, we need to do implicit differentiation. So we can just differentiate each term. Now the x cubed just differentiates to 3x squared, bring the power down and reduce it. The 2xy we need to use the product rule for because we actually have a function of x times by a function of x. So the 2x differentiates to 2. I'm going to get 2y because it's u dash v plus uv dash. And then it's going to be 2x because that's my u times by y differentiated, which is actually dy by dx. So those two terms are me using the product rule on 2xy. And then for 3y squared, I need to use the chain rule. Just like if you had, say, 3 ln x all squared. Actually, let me just ignore the 3. If I differentiated ln x squared, I would bring the power down. It's like I'm doing the outside bit, it's something squared. So I get 2 ln x, and then I times by the derivative of the inside. I'm using the chain rule here, just a quick version of it. It's exactly the same here. Well, the 3 just kind of carries on through. We differentiate y squared, which becomes 2y. So actually I'm going to get 6y. But then I times by the derivative of the inside, which in this case is y. We get a dy by dx. Typically, you just end up whenever you got a y cubed, or sine y, you just differentiate the function as normal, like treating it as x, and then you times by dy by dx. And finally, 47 is going to become 0 when it differentiates. So there we go. Just need to make dy by dx the subject now. So I will factorize out the dy by dx from the two terms that it's contained with. So 2x plus 6y. And then I'm going to minus 3x squared and 2y from both sides, which means my final answer. Now, a really nice way to do it is actually to factorize that minus out and write it as 3x squared plus 2y on top. That's actually the same thing. And then divide by 2x plus 6y. None of this is going to cancel. There's no common factors. So that is our answer. We're then told that the point P minus 2, 5 lies on the curve, and asked to find the equation of the normal to the curve at P, giving our answer in this form. So we've got, I don't know what the curve actually looks like. I mean, it's not going to be a circle or anything like that, but let's just say it looks like this. So what we have is a point on it, and we want to find the normal. So the tangent would be the line that just glances off the curve. In fact, I just need to bring it in a little bit. There we go. And then the normal is at right angles. So we're trying to find this purple line here, essentially. The first thing to do actually is find out the gradient at the point, because that's the gradient of the tangent. So when x equals minus 2, well, y is 5, we already have that. But dy by dx is going to be minus 3 times minus 2 squared plus 2 times 5, all over 2 times minus 2 plus 6 times 5. Okay, and just very carefully work this out. It's going to be 3 times, I forgot the minus. 3 times minus 2 squared, that's 3 times 4, plus 10 over minus 4. If you want to put all the brackets in, you can. It just takes a little bit of time when I'm doing it on the screen. And we get minus 11 over 13. So that's the gradient at the point and the gradient of the tangent. So therefore, the gradient of the normal is at right angles as a perpendicular line. We just take the negative reciprocal, which is going to give us 13 over 11. And we're basically there. We've got our x and y. We've got our gradient. We can use y minus y1 is m x minus x1. That's the recommended one because we don't have to do any rearrange. Well, okay, there will be some rearranging, but we don't have to rearrange to get c and then put it back in. Y minus 5 is going to be 13 over 11 times x minus minus 2. That becomes x plus 2. We've been asked to write it as ax plus by plus c equals 0. You could expand the bracket, but better to just multiply through by 11. 11y minus 55 equals 13x plus 26. So 13x minus 11y plus 81 is going to equal 0. You could instead have minus 13x plus 11y minus 81 equals 0 if you prefer. I mean, they're equivalent and they're both in the form that was asked for. You just have a go at doing the alternative. If you really are a fan of just y equals mx plus c because you mastered that and you just never decided to move on to this one, or you haven't seen it potentially, okay, it's still going to check out. It's just we're going to now put in our I think it was 5, and that's going to equal m, which is 13 over 11 times minus 2 plus c. Of course, it helps that we've got a calculator. You know, if you didn't, then it's much more fiddly. So 13 over 11 times 2. So c is 81 over 11. Okay, then we get y equals 13 over 11x plus 81 over 11. We can times through by 11. I will do actually 11y equals 13x plus 81. And then finally minus the 11y. To be fair, it's not, any worse really. The main reason this this method is not so good is when you start getting sort of things in terms of exponentials. You might have e to the something in there, and it's just like it can be really fiddly to get the value of c because you can't just use your calculator quite as easily if you're leaving it in exact form. That's when this approach really comes into its own. But they are both solid methods, so that's the main thing anyway. This is our answer.